Hi folks, so the question that we have here in front of us today is from the 2015 Junior Cert Higher Level paper, question 6 on the ellipse and the parabola. So starting off any of these questions, look at the image that's given to you, then obviously reading the information that they provide you with up here, because a lot of students would actually forget to read this here, and something here could be important that will help us figure out how to do this down here. So starting off, we'll read the question. It says, the figure shows a design for a scooter. The curve ABC is a portion of an ellipse with semi-minor axis CD. Okay, so ABC is a portion of the ellipse. Okay, so we'd imagine our ellipse would be going like that, but we're only getting this portion of it. And they give us the semi-minor axis CD here. Okay, that's it there. It doesn't tell us the length of it there, but look at the question though. It says the figure shows the location of the axes. So we can see the major axis is going this way because our focal points are on it, F1 and F2. And it also says, and the focal points, and then we can see the minor axis is running C to D, which we were told. So of the elliptical curve, the line BE is a normal to the ellipse. So line BE is a normal. Normal is perpendicular to a tangent. So if we got the tangent, we could go perpendicular to normal, or we can just get the normal by bisecting an angle. Go through that in a while. The line CG is a tangent to the circle from C. Okay, a little bit of circles in contact there, terminology. So we have a tangent here. This line here is a tangent to that circle, radius 15. And then the curve HJK is a parabola with vertex at J. So we see here HJK, that's a parabola with the vertex at J. So that's important there. And then draw the given design showing clearly all constructions. Okay. Little bits here on ellipse principles and how we're going to basically get our major axis to construct our ellipse. So what we're actually going to do here is, we're not given the length of the major axis, we're not given the length of the minor axis, but we are given the length from F1 to the center and F2 to the center. So we're given both our focal points, and we also have this point here B, which is a point in the curve, and as we can see from F1 it's in 23 millimeters and it's up 38 millimeters. Okay, so what we're actually going to use there is a principle of PF1 plus PF2 is equal to the major axis. Okay, what that means, stands for, is the distance from a point on the curve P, or in this case B, to F1. So that distance there, plus the distance from B to F2 is, and if I add those distances, BF2 or BF1 plus BF2, if I add those up, that is equal to my major axis. And once I get my major axis and I've got a point on my curve, I can work backwards to find my minor axis as well to draw my ellipse. Okay, so what you would actually do on the sheet is you would join B to F1, like that. We join B to F2. I would always extend the longer one out. I would take my compass with my compass point on B and the pencil point on F1. I would rotate an arc, and what I've actually essentially found there is that distance there I've essentially just rotated around and I've added it on here, and the distance now from here to here is the distance of my major axis, that distance there. And what we actually only need is half the major axis. So what we could actually do is we could either measure that distance, obviously when we get it on our page, and take half of it, but sometimes that doesn't measure up equally. So what I always tell my students to do is we'll actually bisect that line from here, not B anymore now, but from here to here. And that distance, if I join those two bisected arcs, now what I've essentially found there is from there out to here is half my major axis. So I'll take that distance from there to there, put it on D, that should give me A, and as we can see there, it does. That would be my major axis then. Okay, so that's the first step we're actually going to do on this, and then working backwards, what we're going to do is, given the major axis, we want to try and find the minor circle. From B we'll project up to cut the major axis, join it back through the center, and then come across, and we'll find the minor circle to give us C in a while. Okay, so I'm going to start with that there now. So looking at the sheet, as you can see, I've already located my F1, F2 and D, which is basically the center of my major axis. So what I'm actually going to put in there now, first of all, is my major axis running this way, my minor axis is going vertically. So just putting in my minor axis there. And straight away as well, I'll always note the direction of my major axis. So I know my major axis is this one, MAJ, and I know it's going left to right. Okay, my minor axis, which is this guy here, MIN, and he is going vertically up and down. Okay, that's just a little bit of help there and a little guide for later on. And now what we have to locate is a point B. So from F1 it was in 23 and it was up 38. So just project up a line there and mark up along that line 38 millimeters. And that is our point B, which is on the curve. Let's put it inside. And now what I would do is, like I did in the sheet, I will join B to F1, because B is a point on my elliptical curve, B to F2, and I'll extend F2 out. And what I'm going to do is I'm going to rotate from B around from F1. Try to get the exact point. And what I've now noted there is where that cut right here to here, that distance there from there to there is the distance of my major axis. To find the center, or to find half my major axis, I can bisect that. There to there. Connect those bisecting arcs up. Got the middle of it. Now I've got half my major axis. I can take half my major axis, which is that distance there on my compass, come down to the original center for my major axis and draw in my major circle. In this case I know I only need a quarter of it because I'm only actually drawing a quarter ellipse, so I only need to do it up to about there. Okay, just to keep the drawing neat and tidy for later on. Now at this point we've kind of got the major circle. Okay, from here we've worked out our major circle by using the principle of, and I'll just write it in down here. It is the principle that we used there was the distance from the point on the curve, which in this case was B, to F1, so BF1, PF1, plus the point to F2, PF2, is equal to major axis. So very, very important there. PF1 plus PF2 is equal to the major axis. We have now drawn in our major auxiliary circle. Now what we want to do is we want to find the minor. And that is going to give us, obviously I've located the point A on my curve, which is over here. We want to find C, which is where the minor circle is. Okay, and it's somewhere up along here. We'll just want to find it. And to be able to find that, what we're going to do is, if you have the major axis and we've got a point on the curve, we want to work backwards to find C. Okay, which is the top of our minor axis, to draw in our minor auxiliary circle. So from B, the one I'm trying to find is the minor axis, and we know in that case the minor axis is going vertically. So the one I'm trying to find, what I'll do is from the point on the curve that I do have, I project up parallel to the one I'm trying to find. That is always going to be my first step. Where that cuts the major axis, I'll project that back to the center. And then the one, parallel to my major, from the point, I'll go across, and at that point there, that is a point on my minor auxiliary circle. From here to there, therefore that is the radius of my minor axis and my minor auxiliary circle. So I put in my minor auxiliary circle there now, and once again I only need a quarter of it. Okay, so therefore that point there right now is C. Okay. And often students might just get a little bit confused here in the sense that they might think, why haven't I drawn in the full circle and stuff? Well, if we relate back to the question, we can see I only needed a quarter of the ellipse. Okay, so at this point now, concentric circles method to locate the rest of my points on the elliptical curve. So I'll just speed up the video there now. Right, so as we can see at this point here, I just heavied in that line there a little bit over to roughly this region here, roughly where KLB, and I've heavied in my elliptical curve. Now the next portion of the question I'm going to focus on is this bit here, which is where the seat is going to be, and this tangent bit here. Okay, so it told us up here in the question, it said the line BE It said the line BE is a normal to the ellipse. So we have the line BE here, which is a normal to the ellipse. That means if we were to get a tangent, okay, what you do to get a tangent is you would join the focal points to the point on the curve, because B in this case is our point of contact for that normal. Okay, and I join my both focal points through B, which are already actually done. And what I've actually created there is 4 angles. I have an angle here, 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 and here. If I wanted to get a tangent, and I'm just going to put numbers on these angles, so let's say that's angle 1, this is angle 2, this is angle 3, this is angle 4. Okay, so that angle in there is 4, 2, 3, so on. Okay, if I wanted a tangent, which would be to my elliptical curve, a tangent would go like that. That means I would bisect the angle 2 or 4, which will give me a tangent. But in this case we want a normal, so in this case what I'm going to do is I'm going to bisect angle 1 or angle 3, okay, to give me a normal. Very, very simple after that then, and we get that line that goes up to E, and E we know from B is up a height an extra 15, and it's very simple to complete the seat there. Okay, so that's what we're going to do. We're going to bisect 1 or 3, sorry, once we have extended out these lines. Now, just on this bit here, I have from D up 15, I get my little circle there, and then I have another tangent to the circle from C. So it's very simple. From the center of my circle here to C, I would draw in that line. I would bisect that line. You get the middle of it. Once we have it bisected, obviously I get my bisector, whatever it is. And then I will put from the center of that bisector, okay, to here, which would be my radius. I'm going to take that distance as my radius. I would do a semicircle. And where the semicircle cuts through the circle that I had previously drawn, that is going to be my point of contact for the point G to locate my tangent there from C as well. Okay, so that's the bits I'm just going to move on to there now. So, as I said, join F1 to B, extend it on, and as you can see there, I've got my angles. This line help me get these angles in here. So this is actually the angle that I actually have to heavy in there. So, or not heavy in, bisect. So, from B, which is going to be my center point, I'm going to cut my 2 lines there and there. Then I can change my distance if I want on my compass. We'll keep it obviously for the next point here, and at that point there I will simply join that back to B. There we go, very simple. That's actually my normal. Okay, and it told us from B it was up a height of 15 millimeters. Okay, so therefore from B I'm going to measure up 15 millimeters, measure up 15 there, extend that across. There we go, we can see the portion of my seat there that I'm going to heavy in. That's it there, heavy in the back of the seat here, heavy in this bit going down. There we go, there's my seat. Now to get the bottom portion that's going to be going in here like this, from D I know the center was up a radius of 15 millimeters, or the center was up a distance of 15 millimeters. So using my compass there, just drawing a little circle. In this case I only need, pretty sure I only need a semicircle. I only put in about that much. I know they have a full, look, I'll put in the full circle since it's drawn. But I do know I only need about the semicircle size. So, full circle drawn in there. Now, the next stage is, I said, from the center of this to C, what we're going to do is we are going to bisect that. So, don't know the distance, so bisect it, pick a distance roughly bigger than halfway. There and there. Go to C, do the exact same, here and here, and then connect them up. This point, that point, there we go, there is my center. And with that center point that I have now found, just zoom in there a little bit, okay, with that center point, take the distance from the center to C, do a semicircle, now to there, where it cuts through my original circle radius 15, that point there is now point G, which is my point of contact for my tangent. So I'm just going to put G in there like this. There's G, and I can heavy that in, and I can heavy in the rest of the arc. So I'll just speed up the video there a little bit there now. Right, the next portion of this question, so as you can see we've got the seat done, we have the back portion of the ellipse here. I get the wheels at the very end, okay, but the next portion of this question that's going to pose us a couple of problems possibly is this parabola here. So it says the curve HJK is a parabola with vertex at J. So we can see here HJK. And to locate K, it's very simple. It's from D, it's out 30 millimeters, and then to find H, it's up from K, it's going to be up 80, 40 plus 30 plus 10, and then out to J, we can see it's a distance of 20. Okay, so what we're going to use here is the rectangle method to complete this parabola. Okay, so when we're using the rectangle method, all we're going to do is we know the vertex is at J, so all we're simply going to do is, I'll do it at the top portion of the ellipse and then I can extend it down. So essentially what we're going to do is have a rectangle that simply looks something like that there. So you see that rectangle, and what we're going to do is we're going to split this line up. It's 40, so I might do 10s, so I'll go 10, 10, 10. They're going to go parallel to the axis in this case, which is J, where the vertex is, and then divide this line H here, this one, up into 5s, because 20 goes in 4 times is 5. So 1, 5, 10, 15, 20, so on, and these points here will join to J to give us points on our parabola or parabolic curve, and as you can see they're kind of lining up there. Okay, that's the method for doing that, and then to get the parabola at the opposite side is just a simple bit of axial symmetry. So I'll set that up there now. So from D, out 30 millimeters, that will help us locate the point K. And I know this is just a bit heavy beyond K there as well. And from K then, I'll do a line up. And it goes up about 80 millimeters. So measure up there 40. And then it went up a distance of another 40 to the 80, and I know I need a 10 millimeters here somewhere as well, so I'll do that, just put that in. And at the very top, it's going to be, just label that there, that's my H up here. And then the J is out a distance of 20 millimeters. So right there, that's going to be my J. There's my rectangle, very simple. So I got my J there. And what I need to do now is very simple, complete a parabola inside here. So I have a distance of 40 millimeters here. It's very easy to divide up 4 times. So I'll go 10, 20, 30, and obviously 40. Project these lines down parallel to the axis of the parabola because J is the vertex. And then along here, this is 20 millimeters. 4 times is going to be 5, 10, 15, and obviously 20. And to get the parabola, connect all these points on the outside to J, which is our vertex. That'll help us locate points on the parabolic curve. So point, 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 and what I'm going to do here now is just speed up the video to get the parabolic curve. Now, just getting the parabola at the opposite side, just a simple bit of axial symmetry to help me locate some points here. So all I'm going to do is, once again, if I wanted to find this point at the opposite side, put my compass on the axis line coming from J, which is where the vertex was, take that distance, mark it out the opposite side. So I'll do the same with the other 2 points there and speed up the video. Right, at this point in the question, as you can see, we have got the parabola now HJK drawn. At this point here, it is simply a case of completing the rest of the question, okay? So I've got my wheels to put in over here, my wheel over here. Just on the wheel, we can see from the base of the scooter, it says the bottom portion of the wheel is down 15 millimeters, okay? So it's literally just, so to find the center, I can see the radius of the outside of the perimeter of the wheel, the big one is radius 20. So 20 take 15, that's going to leave us 5. So that means the distance from here up is just a distance of 5, okay, to find the center. And to be the same over here, obviously finding it over here. Doing this bit up here, I've got a little bit of an arc here. It doesn't tell us the radius, we see it just says R. But with the center, it tells us that J is the center of that arc. and I do know where H is, so that arc we can see connects to H. So literally from J as my center, H is my pencil point, that's going to be my radius length, just drawing that bit there, okay? And then it's literally a case of filling all this stuff in here, okay? So we've done all the basic hard bits there. The rest of this should be quite easy, so I'm just going to speed up the video there now, okay, on the rest of it. So there we go there. That is the question completed on the 2015 Ellipse and Parabola question. A few little tricky bits there. Obviously you just have to understand what you learned in class and understand that we only were given the focal points, and we use the focal points and the point on the curve B to be able to complete or find our major axis and then work out our elliptical part of the question, which is often the start point of any of these questions. We can see then here we had the parabola, 40, 20, it was 40 long this way, 20 this way, dividing it up into 4 sections each side, and then using a bit of axial symmetry. And then just the rest of the question, knowing how to get a tangent and a normal, very important. And rest of the question just tidying up these little bits here, okay? So just a little bit there, obviously this little bit here was up 30 to find where that circle finished there. Understand how to get center points, and then learning about the radius bit up here, okay? So once again, hope you found that question helpful there. That's it completed.